Oh, the projector. Oh, okay. So we are continuing 11.4, which is applications involving quadratic equations. And we talked about motions, applications involving motion. So we will now talk about applications involving work. And that's the second time. Yeah. And there is falling distance, and which and I guess that's all. Are you guys ready? All right. Is it on? Good. Now let's share the desktop. That's sharing. All right. What do you guys think if next semester I don't use Math Excel? Is it good or bad? What did you say? So is it better that I don't use Math Excel? Yeah, I'm going to use the book. Of course I'm going to use the book. If I don't use Math Excel, then what else do I use, right? The book better? Old school? Yeah, but I'm going to give like quizzes every day or every other day. So maybe Monday, Wednesday, Tuesday, Wednesday, Thursday. Like quizzes very often. Yeah. Math Excel better? Yeah. Oh, by the way, I changed the due dates of the online quizzes to when? Do you know? Sunday. So do you think it will work for everybody? Okay. So you will do it this time? Yeah, because I'm not going to reopen them anymore. So this is the only time, okay? So for these quizzes, the early ones that you guys took, that's the only one. Okay, so anyway, let's start. Oh, well, actually not start, but let's continue. Now, B is applications involving work. So applications involving work. What I mean by those is something like this. So what's your favorite chore? Well, you don't know. Okay, let's just say we have to paint this room. Okay? And suppose I could paint this room in 2 hours. Ooh. No, probably in 10 hours for me. And Jesus can paint this room by himself. He can paint this room in 6 hours. He's much faster than me. Now the question is, what happens if we both work together? How many hours would it be? So just say I can, by myself, I could paint the room in 10 hours. By himself, Jesus can paint the room for 6 hours. What about together? So that is the type of question when we're dealing with applications involving work, right? So if Jesus is doing it in 6 hours by himself, and I'm doing it in 10 hours by myself, what are the possible hours if we work together? Is it greater than 10? No, it's less than 6, right? Because if Jesus is alone, he takes 6 hours. If I help, then it should be less. Does that make sense? So this is what we're going to do in applications involving work. Now, there are 2 ways to do it. One way is easier than the other. One way is using tables. So we're not going to use the table because it's a little bit longer. How about that? Yeah? Okay. So if you're using my way, then do not put the help button in Math Excel because it will be confusing. So you choose one. Either use this way, which is easier, or the Math Excel way in which you have to do the table. Does that make sense? Okay. All right. So this time is talking about filling a pool. So let's write that down. So the first example would be a well. Well, I mean, this must be an old area. So a well and a spring are filling a swimming pool. Swimming pool. All right. Together, they can fill the pool in 3 hours. Okay? So the well alone can fill the pool in 8 hours less time than the spring. All right. Now the question is, how long would the spring take working alone to fill the pool? All right. So what do we know about them? Together, how long does it take? Together is 3 hours. Okay. Do I know the well alone? 8 less than the spring. Right? Okay. So now this is how we're going to do it if it is the easy way. So if, for example, later on you use Math Excel help, then they use a different way. Yeah, but this is easier, even though the answer is the same. Okay, but you have a table and things like that. Okay, so together how many hours? 3 hours. Now my question is, what about in 1 hour? How much is filled? So if it takes 3 hours to fill, I'm just asking, what about in 1 hour? What part is filled? 1/3, yes. So what do? Take the reciprocal, right? So in 1 hour, 1/3 is filled together. Does that make sense? So if it takes 3 hours to fill the whole thing, what about in 1 hour? It's only 1/3. Yeah. Now, do we know about the well, or do we know about the spring? How long does it take the well? Do we know? 8 hours less. How do you translate that? 8 hours less. X minus 8. Okay. So the well is X minus 8 hours. Good. What about in 1 hour? What happens? What part is filled? 1 over X minus 8. Isn't it? Now, what about the spring? The spring takes how many hours? X hours. What about in 1 hour? 1 over X is filled by the spring alone. So the well alone, and spring alone. Now this is the equation. So part done together is equal to part done by the well and plus part done by spring. Right? Okay. So part done together is part done by the well and part done by the spring. So what part is done by the well, by done together? 1/3. What is part done by the well? 1 over X minus 8. What is the part done by the spring? Okay. So this is your equation. Do you see how you got it? You probably just take the reciprocal of each one of them. Right? Okay. Is this easy? Not too bad. Can we solve it? So this is actually your step 1. And then this is no step 2, so this is step 3. How do we solve it now? LCD. Good. What is the LCD? Times 3. So it's 3x times x minus 8. Yes. Good. And then that's it, right? So 3x times x minus 8. 3x times x minus 8. 3x times x minus 8. Yes or no? Easy? Okay. Then what happens here? The 3 cancels. So you're left with x times x minus 8. What happens here? The x minus 8 cancels, so you're left with 3x. What happened here? The x cancels, so you have 3 times x minus 8. Okay, so can we solve it now? Of course, right? So x squared minus 8x is equal to 3x plus 3x minus 24. Yes. X squared minus 8x is 6x minus 24. Then what do we do? Okay, subtract 6x both sides and add 24. So x squared minus 14x plus 24 is equal to 0. Okay, good. Is it factorable? 24, yes, x minus 12 times x minus 2 equals 0. All right. What is x? 12 or x minus equals 2? Which one is the solution, or are both solutions? Right, you substitute to x minus 8, so 12 minus 8. So 12 minus 8, what is 12 minus 8? 4. How about if I have 2? If I use 2? Yeah, so this is not a solution. Which one is the solution? Just 12. Yes. So 2 is not a solution. Why? Because 2 minus 4 is negative. Right? Okay, so the question now is, how long would it take the spring to fill? Spring is how many hours? And then wells is how many hours? Spring is x hours. So you see here, spring is x, and then well is x minus 8. So spring is 12 hours. What about the well? 12 minus 4, which is 8 hours. 12 minus 8, which is 4 hours. Yes. That's good. Are we okay so far? Yep. Okay. Is it easy? Do another one? Okay. Let's see. It doesn't have too much application. Filling a tank. Okay. Let's do another one. Almost the same. Yeah. But don't you see how easy it is? What do you have to do actually? You just flip, right? If it takes 3 hours, then what part is done in 1 hour? 1/3. Yes. So you just flip basically. So number 2. By the way, does anybody know where Jose Martinez is? Do you guys see him? No? I haven't seen him for a while. Yeah. Okay, so 2 pipes are connected to the same tank. So working together, they can fill the tank in 4 hours. Okay. So the larger pipe alone can fill the tank in 6-hour less time than the smaller one. How long would it take both pies to fill the tank? All right, so how do you do it? Okay, come on. Is it easy or difficult? Not easy, yeah. All right, so together, how many hours? 4 hours. So what does it mean? In 1 hour, what part is filled? 1/4 is. Maybe I should wait for you, right? So in 1 hour, 1/4 is filled. Yeah, good. What about the larger pie? Okay, so there is larger and there is smaller. So what is 6 less than? So the smaller one would be x then? Okay. And the larger one would be x minus 6 hours? Okay, so what about in 1 hour? Is filled, right? By the larger pie. How about for the smaller one? Yes. So basically we take the reciprocal. Okay. So this is our step 1. Pretty easy? Step 2, nothing, so we go to step 3 directly. What's my equation? Together, which is 1/4, is equal to the larger one, which is? Yes. Do you think you could solve this for me? Yeah. What is the LCD here? Okay. Would you be able to do it for me, please? Thank you. Is this hard? No. So just remember, if you see these problems, look at your notes. And if you're looking at the Math Excel way of doing it, then it will be different. Yeah, you have to make a table, okay? And then the rate. So it's probably better if you use this way. It's easier. What was the answer?
12
12 hours? What is the other number that doesn't work? Oh, it's the same thing as the other one? Oh, okay. So you know how to do it, right? Is it, so the same equation, is it x squared minus 14x plus 24?
Yeah.
Yeah, okay. So does everybody get the same one? Okay, all right. Then I don't have to talk about these, right? Now I'm done with 11.4. Oh, actually not. I have to solve for formulas. Yeah, solve formulas for variables. Yeah, yeah, I forgot. Now B, oh no, is it B, C? Yes. Falling distance actually. So it's one more application because this is actually physics application. Falling distance. So C. Falling distance. All right. So an object tossed downward with initial speed v0 will travel a distance of s meters. So an object hold on, give me a second. Tossed downward with an initial speed of v0, actually it's initial velocity of v0, will travel a distance s where s is equal to 4.9 t squared plus v0 t. Yeah. So if you throw an object, boom, like with a force, then the distance that it will travel depends on the initial speed and what else. So why do if I throw it goes down and not goes up? Gravity. So this is gravity, 4.9. Actually no, this is half of gravity. Okay. So do you know what is the Earth's gravity? So the gravity is 9.8 meter per second square. Yeah. The gravity of Earth, the acceleration is 9.8 meter per second square. That's the acceleration, the gravity. Yeah. This is half of it. So half of the gravity, 4.9 t squared plus v0 t. All right. Yes, no? Okay. Now, the question is, let's see. So a ring, or let's just, you want to drop a ring or drop a coin? A ring? Yeah. So a ring, well, somebody is sure angry here. So a ring is dropped from a helicopter at an altitude of 75 meters. All right. So approximately how long does it take the ring to reach the ground? All right. So that is the question. Yeah. So a ring is dropped from a helicopter at an altitude of 75 meters. Approximately how long does it take the ring to reach the ground? What do you think? When I drop a ring, does it have initial velocity? So if you drop something or if you throw something, what is the difference? Yeah, if you throw, you use force, right? So you have an initial velocity. What about if you just drop? It's just 0. What is the initial velocity? Is 0. Okay, good. So how would you answer this question? I'm going to use this formula. Any idea? So basically just substitute the value. So S is equal to 4.9 t squared plus V naught t. Right? S is 75 because to go to the ground it is 75 meters. Yes. Is equal to 4.9 t squared plus what is V naught? If you just drop it, 0. Yes. Initial velocity is 0. So how do you solve for t? Divide both sides by 4.9. All right. So t squared is equal to 75 over 4.9. What about t? So I'm supposed to do plus or minus, but can t be negative? No, so that's why it's just plus. So can you give me an approximate value? How many seconds approximately? Square root of 75 divided by 4.9. Oh, where is my calculator? $3.9 what? Okay, so 3.9 seconds, right? All right. So approximately 3.9 seconds. Is that right? 3.9. Did you guys get 3.9?
Yeah.
No? So you'd have to take the square root of 75 divided by 4.9. So the 4.9 is inside square root. Is it 3.9?
Yeah, 3.9.
Okay. So it takes approximately 3.9 seconds. Yeah? All right. Can we do one more? Okay. What did you guys get? It's not 3.9. So the other one is approximately how far will an object fall in 5 seconds when thrown downward at an initial velocity of 30 meters per second. All right, so how are we going to do this? So what was the formula again? S is equal to 4.9 t squared plus v naught t. So how far? What is it asking then? How far? What is it asking? The distance, which is what letter? What variable do we use? S? Okay, great. So it's asking for how far. So S is 4.9. Do I know t squared? What is t? 5. So 5 squared plus 30 times 5, right? So S is, what is this? Let me check. 200 something. Yes, 272.5 meters. So the object will travel 272.5. Yeah. Is it easy? So this is just substituting the value. All right. Do I know where to? What do you mean? So this is your T, right? T is 5 seconds. And then this is your V naught. So, yep. So you just substitute. Yeah. Good. Oh, by the way, anything that has a naught, so V naught, this is initial velocity, means initial. If we have P naught, it means initial population. So it depends. Anything that has a naught, this is read as V naught. And P naught, P naught. Yeah, that's what it is. Okay. So far, so good? So let's continue. All right. Now, D, solving formula for a variable. So solving formula for a variable. Solving formula. Solve a formula for a letter. Say H. So we will call the letter H. All right. So what I want to do is something like this. Suppose I have W is equal to square root of 1 over LC. Solve for L. So eventually this is something that I want to do. Yeah. So that's later on. But what would you do first? So first we have to clear fractions. Yes. And radicals. Okay. So combine all terms of A. Combine all like terms. So if the only power of A is H1, okay, it can be solved use section 2.2 and 7.1. Okay, so if H square appears, but H doesn't, H doesn't. So if H square appears but H doesn't, solve for H using the principle of square root. If H square and H appear, use the quadratic formula. What is H? That's the variable you want to solve for. Formula. Use the quadratic formula. Yeah. So if H square and H appear, use the quadratic formula. All right. So now let's solve for L here. So I'm going to write it again on a different page. Use the quadratic formula. Yeah. Are you guys ready? No? Okay, let me wait a little bit. Okay, so for example, oh, not yet? Here. I think that's it. So solve for the variable, the indicated variable. Number 1, W is equal to square root of 1 over LC, and we want to solve for all. So what do you think we should do first? Take out the radical. How? Square both sides? Yes. So are you guys ready? Because I have to pull this down. So square both sides. Square and square. Do I put plus or minus? Well, no, you're squaring, so you don't put plus or minus. When do you put plus or minus? When we take square roots of both sides. This is squaring, so we don't put plus or minus. So W squared is equal to 1 over LC. All right. Then what do you do? After we have, how do I solve for L? Can we clear the fractions? How do we clear the fractions? Multiply by LC. Or you could say, oh, this is the proportion. I am going to cross multiply. Yes. Have you seen this before? So W squared LC is equal to 1. Right? Now how do I solve for L? Divide both sides by W squared C. So what is L? L is 1 over W squared. Is it easy? Okay. So now I have to clear the fraction, and I only have L. All right. Now the next one, let me give you a couple. This is the pendulum formula. So T is equal to 2 pi square root of L over G. This is the formula for pendulum. So T is the period. Period is how far it goes back one circle. Yeah. L is the length of the pendulum, and G is for the gravity. For G. Okay. So we're solving for G. What are you going to do? You what? Square both sides? Right? You have to take out the radical. So how do I take out the radical? Square both sides. Yeah. So T squared is equal to what? 4 pi squared, and then what is this? L over G. Good. Now do I have fractions? What do I do with my fractions? You multiply by G both sides, or you could say, oh, this is a proportion, so either way. So multiply by G both sides, I guess. G times G. So this G cancels. G T squared, or you could write it as T squared G, it doesn't matter, is equal to 4 pi squared L. And how do we solve for G then? So this is G, is equal to 4 pi squared L over T squared. Yes, no? Okay. Now, this one also has one. What about if I have here? A is equal to A naught 1 minus R squared, and this is for R. Okay, I want you to try. And then you have to give a space, but I'm going to have to copy this. This is the other one. N is equal to half n squared minus n. Okay, so try those two. So what would you do to solve for R? Square root both sides. What would you do? So this is a perfect square, isn't it? 1 minus R. So what we could do is what? Divide both sides by A naught. So A over A naught is equal to 1 minus R squared. And then what? What would you do here? Any idea? Square root both sides? Yes. So only on this problem we don't do plus or minus, because everything is positive usually. Yeah. So A over A naught square root is equal to 1 minus R. So how do I solve for R? Subtract by 1. So negative R is equal to square root of A over A naught minus 1. And then how do you solve for R? Divide by negative 1. Alright. Divide by negative 1, divide by negative 1. So let's see, what do we have here? R is equal to square root of A over A naught, and this is minus, plus 1. So R is equal to 1 minus square root of A over A naught. Are we okay so far? Yep? No? Easy? Okay. Now, what was number 4? I think this one you have to, it's a little bit difficult. Yeah. So when do you not have to use plus or minus? Here I didn't do plus or minus, you see? When you have formulas, because everything is positive. Yeah. Like gravity is positive, length is positive, period is positive, L is positive, C is positive. So we don't do plus or minus. This is just a plus when we have formulas. Yeah? Good. Now, the next one is number 4. Are you all done? Okay. N is equal to half n squared minus n. So, what are we going to do here? I want to solve for n. How do we solve for n? Oh. Yes. Any idea how we solve for n? So let's get rid of the fractions first. How do we get rid of the fractions? So we could distribute first. So n is equal to half n squared minus half n. And then what do you do? So what do you do here? So we multiply by 2, yes. So multiply by 2. All right, so these cancel. So 2n, well, I have to continue down here. So 2n is equal to n squared minus n. All right. Now, do I have both n squared and n? So here we have both n squared and n. So what are we supposed to do if we have both n squared and n? Quadratic formula. Yeah. So this is when we use the quadratic formula. Now I have to change it to standard form first. So what is my standard form? One side must equal to 0. So then we will have n squared minus n minus 2n is equal to 0. All right. Now, when we use the quadratic formula, do we know what a, b, and c is? What is a? 1. What is b? Negative 1. What is c? Negative 2, n. Right. Yeah. So then we could use the quadratic formula. So n is equal to negative b plus or minus, but we don't use plus or minus. We only use plus. Does that make sense? We don't use plus or minus, we only use plus. Negative b plus or minus b squared minus 4ac all over 2a. What's negative b? 1 plus square root of 1 minus 4 times 1 times negative 2n divided by 2. So this is 1 plus, what about this? Square root of 1 plus 8n divided by 2. That's it. So when do we use the quadratic formula? When you have both n squared and n. Yeah. Should we do another one? I think so, isn't it? Okay. All right. Which one is using the quadratic formula? Oh, here. Number 5. What about if we have a is equal to pi r squared plus pi rs, and we want to solve for r? And what do you notice here? Yes, so pi r squared and pi rs. So it has what? Has both what? R squared and r. So what are you going to do? So use the quadratic formula. Good. So if we use quadratic formula, what do we do? Standard form. So 0 is equal to what? Pi r squared plus pi sr minus a. Yes. Because then you could tell the a and b and c. Yeah. Yeah. What is my a? Pi. A is the coefficient of r squared. What is b? B is the coefficient of r, which is pi s. And what is c? What is it? Negative a. So do you know why I switched this then? Yes, that because pi s is the coefficient of r. Yeah? Okay. Now, what is the quadratic formula? Yes, negative b, but what is the variable? What is the variable? Is it x? No, it's r. R is negative b plus or minus, but I don't include the minus, only plus, square root of b squared minus 4ac all over 2a. So negative b, what is negative b? Negative pi s plus or minus, well, not plus or minus, just plus. What is b squared? Pi squared s squared, yes, minus 4 times pi times negative a divided by 2 pi. So r is negative pi s plus square root of pi squared s squared, what about b? Plus 4a pi or 4 pi a, doesn't matter. Is it? Divided by 2 pi. Alright. Are we done? Yes, we're done. There's nothing else we can do. Is it easy? Yeah? Okay. So this is new. The quadratic formula is new. Usually before, we never use the quadratic formula, right? Okay. All right. I guess we're going to be done now because it's 11:37. But I'm done with 11.4. So tomorrow, it's quite important. It's a little difficult. Equations reducible to quadratic. So please come tomorrow. Yeah. Don't skip class tomorrow. Okay. So 11.5 tomorrow. All right. So I will see you guys later tomorrow. Yeah. All right. So I'm gonna close this, and we're done with applications involving quadratic equations. Tomorrow we will start 11.5.